So in this video, we are going to discuss about peak detector. So it is a circuit which is used to determine the peak, right? That is maximum value of an input signal. So if this is my input signal, okay. So it has to detect the peak. This is your peak, okay. This is your first peak, and after that, it has to detect the second peak, then third peak, then it has to hold that value, then it has to detect the final peak, then it has to hold the value. So it stores the peak value of the input for infinite time duration until it comes to reset condition, okay. So what it is doing, it is tracking the highest peak, and it is holding the values for the certain times. So we have already studied the topic called rectifiers, okay. So the rectifiers, what will do, it will provide an output in the proportion to the average value of the input, right? Output is proportional to the average value of the input, right? So if I want to detect the peak value of the signal, we are using the peak detector. Okay. So traditionally we use AC voltmeter, but here using with the help of peak detector, we can detect the peak of the non-sinusoidal waveform also. So first let us discuss the block diagram of this peak detector. So you have a capacitor, diode, and the up down. Okay. So let us consider the initially the capacitor is not charged. Okay. So it is 0, and this point is also 0 value, and I am giving a signal like this, right? So I am giving a signal like this. Okay. So this is my input signal. So whenever the signal start to increase, so the plus value is greater than the minus value. So this signal only we are getting at the output. So this diode is positive. So right, this becomes positive. So it is nothing but it is a forward bias. So which will make my capacitors to charge, right? So it will charge up to this value, right? So it will charge up to this value. Okay. Okay. So whenever the input signal goes low, okay, whenever this input signal goes low, what will happen? This diode is open circuited, right? If diode is open circuited, so therefore the capacitor has to hold this value, right? But basically we have to use on resistance as a load, that is R. So if the diode is not functioning, that is if the input signal goes low, the diode is open circuited, therefore the capacitor start to discharge its value, right? It start to discharge through this resistor. Okay. So what will happen? It will not able to hold the value, hold the peak values, and then it start to decrease, right? Discharge. So this should not be happen. Okay, therefore what I am going to do, I am going to replace this and also you can see the RC value must be greater than or equal to 10 times the T value, or the RT value, that is the forward resistance of the diode, should be less than or equal to 1 by 10 of T. Okay, so this will make so this condition should be satisfied in order to slow down the process of discharging of the capacitor. Okay, so that what I'm going to do in order to avoid this condition, I'm going to replace this instead of connecting this load resistance, I'm going to connect one voltage follower, that is buffer. Okay, so we know that what is the function of the voltage follower? It has a very high impedance, input impedance, and a very low output impedance. Okay, so that it will prevent the discharging of the capacitance. Okay. Oh, so consider there is one more problem. This is the first problem, and the second problem is whenever the input goes low, this value becomes VP, right? This value is VP now. It value is VP, and this diode is open circuited, right? This diode get open circuited. So you can see if this is charged to VP. Okay, the maximum value, that is VP now, and what will happen? This value only it is obtained at here. Okay, now if this value goes below, and if this value goes below, the input value goes below this VP, so the plus becomes less than the negative value. So you will get since it is positive, and since it is more positive compared to this one, this circuit becomes open circuited. Okay, this becomes open circuited. Okay, so you can see it will act as a open loop. It will operate in an open loop configuration. So in that case, if plus value is less than minus value, this output will go to negative saturation. Okay, it will go to negative saturation. So even if this positive value is greater than the negative value, it will not go out from the negative saturation. That is, it will not be able to detect the fast change in the input signal. Okay. So basically, if instead of the normal diode, if I use Schottky diode, it has a quick response time. Okay, so therefore it will quickly detect the change in the input signal. Okay, so it is not only based on the diode, it also based on the capacitance what we are using, and also it is also based on the op-amp which we are using. Okay, and it is also based on the slew rate. Okay, slew rate measured in terms of del V by del P. Okay, volt millivolt per second. So in order to avoid this problem, okay, so we are going for the modified peak detector.
Right thing. Let's stay thing.
So this is your modified peak detector. So initially the capacitance which we are storing in this it is 0. Okay. So if this is 0, since it is a voltage per hour, this output is also 0. So this point is also 0. So consider my input signal is varying like this. Okay. And if the input signal start to increase, the plus value is greater than the minus value. So this diode is forward bias. If this is positive, this diode becomes open circuited, right? So this is open circuited, and this one is short circuited, right? So the peak value, it will store whatever the peak value it will reach like this. Okay. And if I want, I can connect on switches in order to reset this capacitor value to back to 0. Okay, so this is a MOSFET switch. I can use MOSFET switch to reset this value. Okay, once if the signal start to decrease, okay, if my VN start to decrease, um, uh, so now this before that one it will charge up to VP, right? So let me take this point, is now it is VP. So now this goes to VP. Okay, so if this is VP means this point is also VP, right? There is a this diode becomes short circuited, right? This diode becomes short circuited because this is positive compared to this one, because now the signal start to decrease, so the plus value is less than the minus value. So this diode becomes open circuited, right? This diode becomes open circuited. So you can see, instead of the open loop configuration, I have this is how the circuit for entire this duration. Okay, entire for this duration. So till this one, the Vin will not reach the capacitor, so the capacitor will hold the values up to this value, right? So once if the input signal is exceeding this value, okay, once if the signal exceeding this value, so this plus value is greater than the minus value. So you can see you have a diode here, right? So if the plus value is greater than the minus value, this output is positive. So if the output is positive, this becomes open circuited, and here you have a diode that is short circuited. So again it will goes to the next peak, right? So this entire operation will proceed. Okay, so this modified peak detector will this overcome the problem of negative saturation problem which existed in the previous peak detector circuit. So the application of this peak detectors are First one is it is used in the analysis of the spectral and mass spectrometer, and it is also used to find its application in destructive testing, and it is used for instrumentation measurements, mostly in amplitude moduled wave communication, and it is also used in the sound measuring instrument. Okay. So